Hi there, and welcome to our lecture on chemical reactions. This is reaction 3 of Unit 4. We've got two main key ideas from this section: when do chemical reactions take place, and what is the role of energy in chemical reactions. So to begin looking at the first question, chemical reactions occur when a substance undergoes chemical changes to form new substances. We've got several signs of a chemical change or a chemical reaction. And these will look similar to the chemical change examples that we had in Unit 1. Formation of a gas. So we get some bubbles that form, such as when you add vinegar and baking soda together, it bubbles, causes a gas. Sometimes we get a solid that forms. We call this a precipitate. So sometimes we have two solutions, we can mix them together, and then we can get either a white solid that forms, or maybe the solid is a different color. We can also have the release of energy. We can detect the release of energy as heat. We can detect it as light. Just to name a couple of examples of how energy can be detected. So those are signs of chemical reactions taking place, similar to the chemical changes we talked about before. What chemical reactions do is they rearrange atoms, and we start with our reactants on one side of the reaction. So reactants is the substance that reacts, basically. It's that they're participating in the chemical reaction. And then the product is the substance that forms. So these reactants interact with each other, and then we form one or more products as a result of that. So we can say that chemical reactions do not create atoms of the products or destroy the atoms of the reactants. So back to this previous sentence here, we're just taking what we are reacting, or reactants here, we're just rearranging how those are arranged to form the products. Short little video here for you to watch.
When liquid bromine is added to aluminum foil, the two substances react. Heat and light are indications of a chemical reaction. Aluminum bromide is produced and deposited onto a cooler surface.
Alright, so what is the role of energy in chemical reactions? Chemical reactions always involve changes in energy, whether it's increased or decreased. Energy must be added in order to break the bond, so we do have to have some energy, or something's taking place with our reactants to form our products. We do have several different forms of energy. We can add heat, so we've got our reactants, and put a heater underneath it, or a hot plate, or a flame. We can use electricity, so we can apply a current to our reactants. We could also add sound and maybe even light to cause these reactants to interact with each other, to rearrange and form our products. And then the forming of these new bonds will release the energy then. So the energy is coming in, it forms these new products, and we get some excess energy that's released. So typically we can detect either the release of gas or some heat that is evidence of those products. So that energy is conserved, so whatever goes into it is going to be coming out or conserved within the molecules themselves. Chemical energy is just the energy released when a chemical compound reacts to produce new compounds. And again, the total energy that exists before the reaction is equal to the total energy of the products and their surroundings. So we'd have to also take a look at the surrounding energy. And it is going to change forms, this energy. So we can go back to our conservation, our law of conservation. Energy is not created or destroyed. So it's just changing forms from here to here. So to get a visual of this, let's say we've got this isooctane, this chemical compound. It's reacting with oxygen. So these are the reactants. They're going to interact with each other to form these products. And we get carbon dioxide and water. And we also get some energy that's released as well. What might be missing from this reaction is some energy over here. So we might have to add some energy for this reaction to take place. So I would say we've got some energy. Add energy, reaction, products, release of energy. And just to fill us in here, this is actually a combustion reaction. So these two are reacting, so yeah, there would be a source of energy coming in, and we do get a lot of energy that comes out of it as well. The reactions that release energy, refer to those as exothermic. So exothermic is the release of energy. So the amount of energy released as the products form is greater than the amount of energy absorbed to break the bonds in the reactants. Reactions that absorb energy are endothermic. More energy is needed to break the bonds, and the reactants then is given off by forming the bonds of the products. You can think of an exothermic reaction as the use like hot hands. If you use a hot hands, that would be an exothermic reaction. If you've ever used an instant ice pack, that it gets really cold, that would be an example of an endothermic reaction. So just to throw the definitions down really quick, exothermic, chemical reaction in which energy is released to the surroundings as heat. Endothermic is a reaction that requires energy input. So that's why exothermic tends to feel hot after it reacts, and endothermic tends to feel cold after it reacts. And what we've got here is just a couple of graphs of what the energy input to output looks like. So for an exothermic reaction, there's a lot more energy released. Endothermic reaction, there's a lot more energy absorbed in order to form the products. Thanks for listening.